Hello, can you hear me?
Hello. Yes,
Okay, so how are you?
I'm fine. How are you?
I'm fine, thank you. So we will start our second day's class.
Yes, yes.
Recording in progress.
Can you see my screen?
Yes.
Uh, So hi and welcome to the 7 days course on Google Earth Engine for beginners to advanced remote sensing analysis. So basically this course will be taken 7 days and we already covered our first day. And I am course coordinator. So this is our full course content for total 7 days. We will complete all of the topics within the 7 days. And today is our second day. Okay. So second day course content will be that I will try to discuss about that how you can easily filter and displaying the satellite images, mainly Landsat and Sentinel, both images. How you can easily filter and display the satellite images. Okay, and then how you can easily use the different types of band combination on your satellite images. Suppose true color composite, false color composite, natural color composite, different types of band combination, how you can easily display. Then how to export this satellite imagery. Suppose you want to export the Landsat imagery for any particular region, how you can do this. I also try to show you that how you can easily export the satellite imagery. Then how to import, filter, reduce, clip and display data in Google Earth Engine platform. Suppose in the we already know about that Earth Engine public data catalog. Earth Engine public data catalog provide you lot of data set. Okay, so how you can easily import this data set on your code editor, then filter, then reduce, okay, and then clip on your shape file and display the data in Google Earth Engine platform. After this we also try to discuss about the time series chart of Ndvi, how you can easily make the time series chart using the Modis data, how you can easily make the time series chart using the Landsat data. Okay, and this is the same process. And then how to export any shape file from your Google Earth Engine platform. It can be river shape file, it can be any water body shape file or lake shape file, any shape file, how you can easily export from the Google Earth Engine platform. Then how to calculating any indices from satellite images. Suppose how we can calculate the Ndvi using the formula of Ndvi, near minus rate divided by near plus rate, or any other equation, how we can easily calculate any indices. Then this is our full course content for today. We will try to step by step, then we will also try to finish. Okay, so first of all, Earth Engine public data catalog. Okay, so this is the open public data catalog. Anyone can access all of the data: Landsat, Sentinel, Modis, train, land cover and atmospheric data, and it daily updating daily. Okay, so we can easily access more than 200 public data set, more than 4000 new images every day. Every single day we can get. Then we can get the more than 5 petabytes of data and more than 5 million images using this public data catalog site we can easily access. And this is the website for the Earth Engine data catalog. We can easily access all of the dataset from this link. So I simply open the link in a browser. So for this I simply just copy this link from here and open in my browser. So I simply copy, and then I simply open in my browser. So it provided you all of the Earth Engine public data catalog. Here I can access the Landsat, Modis, Sentinel, different types of climate and weather data. Also you can see surface temperature, climate, also it's atmospheric data, weather data, different types of imagery, Landsat, Sentinel. Also you can see Modis, high resolution imagery. Okay, also train, land cover. Okay, different types of raster data we can easily access from here. Okay, and this is our Earth Engine public data catalog. Okay, so in this time you can also see this is the Landsat. Here I can get all of the collection of the Landsat. Okay, So Landsat 9, 8, 7, 5, different types of Landsat classification, top of atmospheric dataset, then surface reflectance dataset. Okay, you can see this is Landsat 9 surface reflectance, Landsat 8 surface reflectance. Okay, also you can see top of atmospheric data, Landsat 8, Landsat 9, Landsat 7. Okay, this is the raw image. Okay, all of the collection we can easily access from this Earth Engine public data catalog. Also you can see Sentinel. Here you can get the all of the collection of the Sentinel, top of atmospheric, Sentinel 1 SAR data, multispectral instrument, Sentinel 5, Sentinel 3, all of the satellite imagery we can easily access from the Earth Engine public data catalog. Also you can see MODIS. So in this time here you can get all of the MODIS data. Okay, so it can be daily product. You can see this is the daily product, it will be updating daily. Okay, so here you can see
Yes.
daily product, different types of daily product, also derived products you can see. Okay, so in this time I will try to show you that how you can easily import this data on your code editor. So you can see this is my code editor. I also open my code editor. In this time, suppose I want to work with any data set. So first of all we need to import this data set on my code editor, then work with it. Okay, so in this time suppose I want to work with this data set for the MODIS Ndvi data set. Here you can see I want to work with this data vegetation indices 16-day global 250 meter resolution. I want to work with this data set. Okay, so first of all this data set I need to import my code editor. Okay, so how I can import this? So I simply click on here. Now we can get all of the information about this data set, about the MODIS trap vegetation indices. So here I can get all of the information about this data set. Here you can see this data set availability date. Okay, we can access this data set between this time period. We can access the data set between this time period. It will be start year of 2000 and present time we can also access. Okay, also you can see this is the data set provider. You can see this is the data set provider. Also you can see Earth Engine snippet. Actually this is the unique ID of this dataset. Okay, so this is the unique ID of this dataset. Okay, and also you can see different types of description about this dataset. Okay, and also you can see this dataset provided with the two band. First band is the Ndvi, normalized difference vegetation index, and second data is the EVI or enhanced vegetation index. Okay, so in this time I want to work with this dataset and I want to work with the Ndvi band. Okay, so first of all you need to import this dataset. Okay, so we can import the dataset two way in my code editor. First way is that you can simply copy the Earth Engine snippet from here, simply copy and then simply paste here. Okay, simply paste here. Okay, then you can simply put a variable name. I can simply put the variable name. Suppose this variable name is the MODIS. Okay, sorry, this is the MODIS. I simply put the, you can use any name. I simply use here the MODIS. Here you can see this is my Earth Engine snippet or unique ID of this dataset, and every dataset you can get the Earth Engine snippet or unique ID of this dataset. So I simply copy this dataset and paste in my code editor. So here I can get, you can see now this dataset is imported in my code editor. Okay, so this is the one way. You can simply copy the Earth Engine snippet and paste here. After this you can just include a variable name. Okay, so in this time you can see this is my whole collection of MODIS Ndvi. It's stored in a variable. This variable name is the MODIS. So this is the one way. Another way is that you can simply search in here. I need to MODIS Ndvi. I simply search here the MODIS Ndvi. Okay, so now you can see it's provided the MODIS Ndvi terra vegetation, all of the collection will be provided. I want to work with the terra vegetation indices 16-day global 250 meter resolution, this data set. Okay, so I simply click to here and we can get the same information. All of the details will be same in here. We can get the same information also here. Okay, so in this time I simply click to the import. You can see this is the import option. When I simply click to import, this dataset also imported. Okay, so this is the another method. Okay, if you want you can simply copy the Earth Engine snippet, or if you want simply search here and then click to the import, then this dataset will be imported in your code editor. Okay, so this is the import part. In this time you can see this dataset is imported in my code editor, and here you can see this is the default variable name you can see this is the image collection. It will be showing the image collection. Okay, and if I use the first item, so I simply remove this. Suppose you can say I import the dataset, just click to import, it will be imported. And other method, just copy the earth snippet and paste here. You can use the anyone, no problem. So in this time I use the, you can see it will be default showing a image collection, and it's showing the purple color. If you want, you can change the variable name. It's for your more convenient. I simply use the name is that, suppose modis. Okay, in this time here you can see this image collection. This is my image collection, and it is stored in a variable. This variable name is that modis. Okay, and in this time here you can see, in this time I need to select my specific band, which band I want to work. We already know about that. You can see this modit provide you the two band, Ndvi and AVI. In this time I want to work with the Ndvi. So for this you need to select your own band, which band you want to work. So I simply use a band. So I take a variable. You can use any variable name. I simply put the variable name is the Ndvi modis. You can use any name. Okay, then you can see my full collection or my whole collection, it is stored in a variable. This variable name is the modis. Okay, and this modis has a two band, Ndvi and AVI. From this modis I want to select only for the one band, Ndvi. So I simply call my modis, because it will be stored under this variable modis. So I simply use here the modis. Then I simply use here the select function. So I want to select my specific band. My specific band is that Ndvi. Okay, so you can see this is the modis, this is the variable. This variable is stored my full collection or whole collection, and this whole collection has also two band, Ndvi and AVI. From this whole collection I select only for Ndvi. So I can simply write this code, Ndvi modis. From this modis I select Ndvi band. Okay, and it is stored in a variable Ndvi modis. Okay, so now I want to check how many images will be available for the whole world. For the whole world, how many images will be available between this time period, year of 2013, year of 2000 to present time. How many images will be available?
22.
I want to check it. Okay, so I simply use here the print function, because in this time I want to print it. I want to print this, you can see Ndvi modis, because my modis image or modis band is stored in a variable. Okay, so I simply use here this variable name. This is the modis Ndvi. I simply copy and then simply paste here. After this I need to add the another function. This function called the size function. Size is a function. It's determine how many images will be available in a particular collection. Okay, so I want to check it, so I simply use here the size function, then click to the run. So now you can see how many images will be available for the whole world between this time period, year of 2000 to present time. Okay, so you can see we can get total 501 images. Okay, for Ndvi from modis data. So in this time here you can see, yeah, in this time suppose I want to need only for any particular time period. I don't need to the whole time period. I need suppose 5 years, year of 2015 to 2020. I need this time period, or any 1 year, or any 2 year, or any 5 year, any time period you can select, no problem. Which time period you need, you can simply select the time period. Okay, I want to select the time period, suppose between the year of 2015 to 2020. I want to need the data. Okay, between this time period. So I simply take a variable and give the variable name is that. I can simply use the variable name is the filter Ndvi. Okay, filter Ndvi. Here you can see this 501 images. What is the time period? This time period is that you can see between this time period. Okay, year of 2000 to present time. But in this time, from the 501 images, I want to select only for those images which image will be available between the time period year of 2015 to 2020. Okay, so I simply call the Ndvi modis. I simply call the Ndvi modis because it stored total 501 images. Okay, then I simply use a function. This function called the filter date. Filter date. In this time I want to filter my date, so I simply use the filter date. and you can see what is the argument start and end date. So I simply put here my time period, what time period I want to need. In this time I simply use here the year of 2015, sorry, 2015, suppose 1st January, okay, and in date I simply put here the year of 2020, December 31, okay. So I want to calculate, you can see 5 years data, so I simply put here, and now I want to check how many images will be available between this time period, okay. I want to check it, so I simply call the filter Ndvi, simply copy this variable name and paste here. After this I simply use here the size function, okay, size, and then click to the run. So now you can see it will be showing the 138 images, 138 images between this time period. I want to get 138 images. In this time, here you can see in the next step I want to calculate the mean of all images. You can see I want to check the time period, all of the images, when this image will be captured or created. So I simply use here the print function, and then I simply copy the variable name and then click to the run. You can get all of the information about these images. You can see total 138 images. Click to the feature. Here we can get every image, we can get 16 interval. You can see first image will be 1st January, then 17th January, then 2nd February, then 18th February, 16-day interval. So that's why this data set called the 16-day global 250 meter resolution, okay. So in this time I can get the every 16-day images. In the next step I want to calculate the mean. You can see I want to calculate the mean of all images. I want to calculate the average Ndvi of all images. So in this time I want to calculate the mean of all images that we get after applying the date filter, and we will use the mean reducer to our data, which reduce the image collection by the calculating the mean of all values is pixel across the stack of all missing bands, okay. So in this time I will try to show you that. So you can simply take a variable and give the variable name is that mean Ndvi, okay.
Okay.
I simply use the mean Ndvi, and then you can see my 138 images is stored in a variable. This variable is the filter Ndvi. I simply copy the filter Ndvi and then paste here. After this I simply use a function, this function called the reduce function. So reduce is an statistical function. In this time I want to calculate the average pixel value of all the images. So that's why I simply use the reduce function, and then I use here the ee dot reducer dot mean, okay. It calculated all of the images average pixel value, okay, and it stored it in this variable. In this time I want to show the result on my map, okay. So that's why I simply use my layer. My layer is the map dot layer, and then I simply my object name is that I can mean and Ndvi, simply copy and paste here. After this I will later add the visualization parameters, so I simply remove this and then I click to the run. So now you can see it will be showing the mean Ndvi between the time period year of 2015 to 2020 for the whole world, okay. So now you can see I did not add any visualization parameter, so that's why it will be showing look like this, okay. In this time you can say I add the visualization parameter in here, so that we can easily understand where the dense vegetation and where the low vegetation we can easily understand. So in this time I will do this. So I simply, you can see this is the code, they already provide some visualization parameter. I simply copy, okay, and then just paste in my code editor in here. In this time you can see they are make a dictionary, so that's why they are use a curly bracket, okay. Curly bracket start and curly bracket end. They are put here the keyword and key value. So in this time you can see they are put here the mean Ndvi pixel value. It will be start from the 0 and up to max pixel value 8000, and they are also provided the some color plated in a list. They also make a list. You can see this is the list, and in the list they are provide some color plated. In this time we already know about that. After the object name, this is my object. After the object name, we always need to put here our visualization parameter. So my visualization parameter is the Ndvi vis. I simply copy this name and paste here. So now this visualization will be added with my map interactive view. So I simply click to the run. So now you can see. So now you can see, let's display our data on the map, and we can see how fast it works. We have calculated the mean of all images between the year of 2015 to 2020 within a second for the whole world. Okay, so you can see this is our Ndvi map for the whole world between this time period. And in this time, suppose I don't need to the whole world, I need only for my own region. Suppose on country or on my shapefile or on my own boundary area, I want to need this result. I don't need the whole world. Okay, so that then you need to first of all you need to filter import your shapefile. So I already covered this part, how you can easily import your shapefile. So in this time I use this dataset from Earth Engine. Suppose US DOS dataset, I can get the country boundary shapefile from here. Okay, so USDOS dataset, it provide the country boundary shapefile. We also covered this part. So I simply import this dataset, and then I just filter my own country, which country I want to need. I simply use here the take a variable and give the this is the country variable, and then I simply call my collection of the USDOS table. So I simply use here the table, and then I simply use here the filter function. How I can filter? I want to filter Earth Engine.
Filter dot
filter dot equal what's equal what. In this time I put here the country name, country NA, and then I simply put here this, suppose any country, I simply put here this Bangladesh. Okay, in this time you can see I imported my shapefile Bangladesh, and it is stored in a variable country. Okay, so in this time I just, you can see this map display what's the variable display this map? Can you guess it? What's the variable?
map display in mean Ndvi.
Yeah, mean Ndvi. Just I need to clip this mean Ndvi with my shapefile variable, then it will be clipped with my region of interest. Okay, so in this time I simply take a variable. Suppose this variable name is the study area, and then you can see this is the mean Ndvi. It's showing the whole world. Okay, it's showing the whole world. In this time, from the whole world I want to clip my own area. Okay, so I simply use the clip function, and then you can see what is the argument, geometry, and my geometry is that, you can see, country. This is my shapefile. I simply copy and then simply paste here. Okay, in this time you can see my final object, I want to show my result for my own country. Okay, and it will be stored in a variable study area. So this is my final object. I simply copy this and just paste here instead of mean Ndvi, and paste here. Okay, suppose I also want to focusing the shapefile, center of this country boundary shapefile of Bangladesh. So I simply use here the map.center object function. And I just put here my object is my country shapefile variable name. You can see country. I want to focusing the shapefile. Okay, so I simply use here my country variable name, and then I simply put here the zoom level is the, suppose, 10. On complete I simply remove it. Okay, then when I click to the run, in this time I can get the Ndvi map of Bangladesh. This is the Ndvi map of Bangladesh. If you want to, you can see, if you want to change the name, suppose I want to need the another country, suppose India, I simply put here the India, and then click to the run. Now you can see, now this data will be provided you only for the India country. Okay, suppose you need the another country, you can simply put the country name, suppose Pakistan, and then click to the run. You can get the Ndvi map of Pakistan. And we can easily export this map as a TIFF format, and we can also make the map layout and everything. You can see like this. Is it right? You can easily export this map, and you can easily make this map like this using for your research paper as well as also your presentation work. You can easily make the map like this, okay, using the ArcMap software. Okay, so I open this. You can see this. Actually, you can see this is the Ndvi map between this time period, year of 2050 to 2020, and we can do everything in Google Earth Engine platform, and then just download the TIFF image. Okay, after downloading the TIFF image, we can easily make the map layout, map title, map legend, everything we can easily do using the our ArcMap software or QGIS software. You can easily do it. Okay.
Okay.
And present and add your research paper or presentation work. Okay, so I also try to
What
show you
will
this.
what will be the cell size of that map?
Cell size means
Resolution.
visualization is this data visualization. You can see 250 meter resolution.
Resolution of it,
Yeah.
250 meters. Okay, okay.
This resolution you can see this 250 meter. It's depend on your satellite imagery. So in this time here I use the 250 meter resolution imagery of the Modis Ndvi. When you want to add the Landsat, then you can get the 30 meter resolution. Okay, so it depend on your satellite imagery. Okay, so you can get the all of the country Ndvi easily. Suppose I want to need the Australia, simply use the Australia and then click to the
How can I export it?
and you can also export it. I also try to show you that, no problem. Okay, and how you can easily make the map like this, I also try to show you this, no problem. Okay, everything you can learn from here, no problem. Okay, in this time you can see this is the presented the map of the Australia in here. And in this time I randomly show you the one dataset for the Ndvi, but here you can see lot of dataset will be available for here. Ndvi, then LST, every dataset you can use the follow the same procedure. Okay, Modis product you can see same procedure. You can when you work with this dataset, you can follow the same procedure. When you work with this dataset, you can follow the same procedure. All of the dataset will be same procedure. You can see snow cover daily, it's also same procedure. You can also see land surface temperature. All of the things will be same procedure. Okay, you can also try to use the dataset for your own region. Okay, no problem. Okay, so you can practice. So here you can see in this time I can get the dataset in here. Okay, but this dataset has also problem. This problem is that you can see we already know about that Ndvi value range. So you can see Ndvi value range is that between here you can see Ndvi value range. This is the Ndvi value range, positive 1 to negative 1. Okay, this is the range of Ndvi. Okay, value range. In this time, when you want to check the value of Ndvi any particular region using the inspector tab, you can see I can get the value 3410.
Oh my god.
I also get the value, you can see 40. In this time this data is not reprojected our scale value. Okay, so we already know about that Ndvi value is the -1 to +1, but this data is not reprojected. So that's why you also need to reprojected this data and work with this. Okay, so in this time I also try to show you that how you can easily reprojected this data and you can get the value within -1 to +1 this range. Okay, so for this you can see this data set has also you can see band. Okay, you can see this is the band Ndvi, and you can see this is the default mean and max value this. Okay, and it's not our Ndvi range -1 to +1. Okay, this range is not maintained, so that's why they are also provide a scale. You can see they are also provide a scale. Okay, this is the scale value. in this time I just multiply with this scale value with my whole collection. In this time you can see between this time period I get here from the 138 images. Okay,
Yes, yes.
in this time these 138 images I just multiply with this scale factor. My scale factor is that you can see 0.001. I just multiply this value with my total 138 images. Okay,
Right.
and these 138 images stored in a variable. You can see stored in a variable. This variable name is the filter Ndvi. This filter Ndvi stored total 138 images. Okay, in this time I just multiply with my scale factor because I want to need the maintain the range of Ndvi, -1 to +1 or +1 to -1. This range I want to need the value. So that's why I just multiply with my scale value with this whole collection 138, and it is stored in a variable filter Ndvi. Okay, so for this I can simply do this. I take a variable and give the variable name is the scaled Ndvi. Okay, in this time here you can see these 138 images stored in a variable filter Ndvi. I simply call the filter Ndvi and paste here. Okay, in this time I just write a function. In this time. So we already know about the function. When you want to create a function, first of all you need to create a function keyword. Okay, and first I also try to discuss about that. Create a function. Okay, and you can see this is the function. I simply use the parenthesis. Between this parenthesis I need to add here my element name. In this time my element name is that, suppose this 138 images I take a variable and store this 138 images in a variable. This variable is called the, I can simply put the variable name is the img. Okay, and this img or image, you can see this image store a total 138. You can just suppose that this image has a 138. Okay, and now I want to use here the curly bracket, and between this curly bracket I write what is my argument, what I want to need. I want to return from, so I simply use the return function. I want to return from this image img. This image, it means that 138 image. This image means that 138. Okay, I want to just multiply. I want to return from this image will be multiply the scale factor. What is the scale factor? You can see
0.001.
Yeah, so you can just simply use the value
0.0001.
Yeah, simply copy this value and
0.0001.
paste here.
Okay.
In this time what's happened, you can see this is my function I created. This function means this is the image. I also remove this, I also add the letter so you can easily understand. So we already know about that. When you want to create a function, first of all you need to create a variable name. This is the scale Ndvi. Okay, then you also need to use here the equal sign, then use here the function keyword. Okay, after this you need to use here the parenthesis. Okay, this parenthesis you need to element name image. Okay, in this time I said that this image is equal to 138, but you can see there is the no connection with the filter Ndvi. Okay, there is the no connection with the 138 images. So we also, after completing this function, we also add this function. Then we also need to add the another function. So we also try to discuss, no problem. So you can see in this time I use at the curly bracket. Okay, and in this curly bracket I simply returned what I returned. I want to return from this image multiply with this scale factor. Okay, scale value. In this time I also need to have another function. This is the copy properties. Copy properties is a function. It copies the metadata properties one element to another. So in this time one element to another I want to need, you can see I want to need only for the one image. You can see there is a total 138 images, and I want to apply this, I want to multiply the whole image. So every single image, you can see this is there is a lot of images. Every single image I want to multiply with this value. Every single image I want to multiply with this scale factor. Okay, so that's why I need to use here the copy properties. And you see what is the copy properties. It's copies metadata properties from one element to another. So it's copy metadata from one element to another. So that's why I want to multiply all of the images with this value. So that's why I simply use the copy properties. I want to add the copy properties with my image, because this is why I write the image in here. This image, I suppose that this image included total 138 images. Okay, so that's why I simply use here the image, and then I simply use here the define it, the system time start, and also I am to define here the system time end. And why I write this, you can see in this time I already define a time in here, start time and end time already defined, and my image also provided according to this time period. Okay, so that's why I also define it. When I multiply with my this scale factor with my all of the images, it's maintain this time period, system time start and system time end. Which time set the system, it also maintain the same time start and end. So that's why I simply use the system time start and system time end. In this time, this is my function which I created. In this time, this function has no connection with the filter Ndvi. So that's why why it will be image equal to 138. Okay, because you can see there is no connection. In this time, you need to connect this function with the filter Ndvi. I need to connect the function, this is my function, with the filter Ndvi. Okay, so for this you can simply call the filter Ndvi and paste here. After creating the, simply paste here. Okay, then I need to connect this function. So that's why I need to use here a function, this function called the map function. After this, simply use here the parenthesis, and then simply cancel this parenthesis, and then also in this parenthesis in here. Okay, so you can see this is the map function. It will be connecting your function which you created. It will be connecting this function with your collection, total 138 images. So now this image taken automatically, taken this 138 equal to image. Okay, it will be stored this image element. Okay, so now you can see it will be reprojected, and under the reprojected all of the image including this scale Ndvi, I want to check how many images I can get after the reprojected. I want to check it. So I simply use here the print function, and then simply use here the scale Ndvi. Okay, and then also use here the size function, and then simply click to the run. You can see we can get the same images because I use here the image copy properties, one element to another element, the same properties. Okay, here you can see first of all I can get the filter Ndvi 138 images. I also use here the scale Ndvi, I also get the 138 images. But in this time, this 138 image is not reprojected our scale value, and another 138 image is reprojected our scale value. Okay, so in this time we can do all of the map using this 138 images, because this 138 images is reprojected our scale value. Okay, so in this time I want to create the mean Ndvi using the 138 images, and you can see this image is stored in a variable. This variable name is the scale Ndvi. I simply copy the scale Ndvi and then simply paste here. Okay, and after 1 minute I also send you the Zoom link, so please join. So here you can see I simply copy the variable and paste here scale Ndvi, and everything will be same. Then I simply click to the run, but you can see I can get a totally white color map. You can see
map centered.
You can see I can get the white color map. Why I can get the white color map? You can see it's problem in my visualization. In here you can see it will be showing up to the from the 0 pixel to 8000 pixel, but I reprojected this scale value so that I can get the range between the -1 to +1. So I simply use here the -1 and also put here the +1. Okay, and then click to the run. So now I can get the result. You can see Ndvi, and in this time here you can see the green pixel value. It doesn't matter because it's showing as a this color plated. Okay, this color plated which you set this, it will be showing this. If you want, you can also change it. Suppose I simply change the color plated in here, and suppose I want to show the blue color.